Alright, at this time, if you would, go ahead and clear your desk except for 2 clean sheets of paper and a pencil. You've had about 3 or 4 minutes to study over those last minute cramming over your squares, your cubes, your powers of 2. So this time, 2 clean sheets of paper and a pencil. One of the sheets of paper will be for a cover sheet. On the other sheet of paper, first and last name at the top along with today's date. Today is 4/19/21. 4/19/21. And let's just call this Powers Quiz 1. Powers Quiz 1. Now sometimes at the top of a web page or something it'll say page 1 of 5 or page 1 of 3 or page 1 of 1. Really not sure how many we're going to end up taking here, but this is at least Powers Quiz 1. Number down then 1 through 16. Number down 1 through 16. I will give you each power twice. You simply need to write the answer. Now, if you want to copy the question down as well, you may, particularly if you're not sure right away and want to maybe see if you'll have time to come back to it. But all I need you to write down are the answers to each of these. All right, number 1. What is 20 squared? 20 squared. Number 2. 14 squared. 14 squared. Number 3. 19 squared. 19 squared. Number 4. 8 cubed. 8 cubed. Number 5. What is 4 cubed? 4 cubed. Number 6. What is 17 squared? What is 17 squared? Number 7. What is 2 to the 5th? 2 to the 5th. Number 8. What is 6 cubed? 6 cubed. Number 9. What is 15 squared? 15 squared. Number 10. What is 5 cubed? 5 cubed. Number 11. 7 cubed. 7 cubed. Number 12. 10 cubed. 10 cubed. Number 13. 2 to the 6th. 2 to the 6th. Number 14. 13 squared. 13 squared. Number 15. 16 squared. 16 squared. And number 16. 2 to the 4th. 2 to the 4th. All right, let me go and collect those from you. And we'll take another quiz tomorrow and see how all that goes. For now, if you would, go ahead and let's take a look at a couple of word problems together. Let's go and have your notes out. And we'll get to the homework here in just a moment. But I wanted to first of all go over a couple of word problems using systems of equations. And let's see here, if we could have Noah go ahead and read this first word problem for us. I know we're a long way removed from Christmas, but I guess that's why they're being packed up. Go ahead and read it for us.
The dealer packed 1,800 Christmas trees into 6 barrels and 6 cases. The next year he packed 2,250 wreaths in 9 barrels and 7 cases. Find the capacity of a barrel and of a case.
All right, so how many unknowns do we have here, Noah?
2.
And what are they?
Barrels and cases.
Barrels and cases. Specifically, what about a barrel or a case?
The capacity.
the capacity, the number of reeds that fit in a barrel and a case. But since I'm too lazy to say how many reeds fit in a barrel and how many reeds fit in a case, I'm just going to say barrel and case. But we understand, make sure I spelled that correctly. Yeah. And so we're going to represent these unknowns, Noah. X and Y. I mean, if you want to get more creative, by the way, and you said, I want to represent them B and C. Could you do that, class? Sure. In fact, in some cases, that may be beneficial. Now, my only concern might be, if you're not careful, your B's might look like 6s, right? And like L's, if you don't write them cursive, could look like 1s. S's could look like 5s. T's could look like, you get the idea. So that's the reason why generally I'll go with X and Y. But I mean, not to stunt your creativity at all. If you wanted to use a letter that represents better the word specifically, so you don't get mixed up, wait, which one was X and which one was Y? Well, if you use B and C, there's no way you're going to mess that up. Just for variety's sake, I'm going to go ahead and do this way. The very first sentence tells us that 1,800 reeds managed to fit into 6 barrels and 6 cases. Each barrel holding how many reeds, class? X, or in my case, B. And each case holding how many reeds, class? C, or Y. At your C's, write your first equation. And Maddie, tell us what you wrote. That was an equation? Or I'm going to say 6b plus 6c. There we go, 1,800. 6 barrels times B reeds per barrel plus 6 cases plus C reeds per case equals 1,800, or perhaps 6x plus 6y equals 1,800, as Maddie said. How many had the same equation? All right, any questions on that? At your seats, write your second equation. We've got this dealer packing 2,250 reeds into 9 barrels and 7 cases. It's a lot of Christmas reeds. A lot of holly jolly Christmas. All right, and Brecken, what was your second equation?
9b plus 7c equals 2,250.
There we go. Or perhaps 9x plus 7y equals 2,250. Did you have the same second equation? All right, we looked at a similar example. Remember where we had like raspberries and cherries or something in our last word problem where it wasn't so much the number of each. We know how many barrels, we know how many cases, we knew how many the cartons or whatever of raspberries and cherries, but it was how much money per container or how many reeds per container, that kind of thing. Thoughts on how we might solve this? There's a couple ways we could go here. Noah? Circling back to you in White House spokesman fashion. For those who've been keeping up with that. Any heard about the White House spokes? Her famous line, I'll circle back to you, I'll circle back to you, I'll circle back to you. Because she never wants to answer any questions. Yeah. Come a long way from the transparency of the past administration that just came out and answered questions. But anyway, I digress. This is not a political talk show.
Multiply the top by 3 and the
Okay.
bottom by 2.
All right, we can multiply the top by 3 and the bottom by 2. And the alternative might be, you see, we could knock a 6 out of the top. And that would actually give you the flexibility of either going substitution or then multiplying maybe the top through after you've knocked out the 6, maybe then multiplying by a 7 or something. But, you know, it's really up to you. Let's go with the way that Noah said. Noah, that means your top equation is going to become
18x plus 18y equals 5,400.
There we go. And then the lower equation.
18x plus 14y equals 4,100.
Now, before we continue working, I do want to point this out. Noah, if we were to knock a 6 out of the top, what would it look like?
B plus C equals 300.
Right, and if we were to multiply a 7 then through that, it would give me a
70 plus 7C equals 2,100.
Did you realize you actually did those 2 steps faster than you did this? Did you notice that? In some cases, the shortcut really is a shortcut. Sometimes it's actually a longer way around. Here, just because the numbers were so easy, where here they weren't quite as easy, just a thought, just consider. It's not, doesn't make this wrong in any way. Just, something to consider as far as alternatives, options. What now, Maddie? All right, and what does that give us when we add the equations together? All right, and then we have to divide both sides by 4, anyone. To get C, the capacity of a case is... Call it when you've got it. $225. We divided by 4. Right? 4 goes into 9 2 times with 1 left over. 2 goes into 10 2 times with 2 left over. 2 goes into 10 5 times. Well, you can divide it on your own paper. You don't have to look. 225 is the answer. You got another number. That's not good. We need to divide by 4. All right, so should get 225 wreaths to a case. Now, Noah, here's where going back to, remember the B plus C equals 300 we had? Man, wouldn't that be nice to just plug the 225 in right there? And now, class, we can get B equals 75 really easily, right? So 75 wreaths fit in a barrel, 225 wreaths fit in a case. So apparently a case is much larger than a barrel. Questions on this word problem, or this word problem? Questions on this? All right, let's take a look at another one together. Read this one for us, if you would, Bracken.
2 paintings sold in an auction for $1,925. If one of them had sold for $15 less and the other for $10 more, the prices of the 2 would have been equal. Find the price of each.
All right. How many unknowns, Bracken? 2, which is good, because it would be hard to use the system if we didn't have 2 unknowns, right? And what are the 2 unknowns? The 2 paintings, right? So we could call, is it first painting and second painting, because I really don't know anything else about them. First painting and second painting. And how might I represent these 2 unknowns? Yeah, P and P really wouldn't work, would it? So like trying to go with whole the alliteration thing or the first, yeah, just go with X and Y. Good fallback option here. And thoughts on what our first equation might be? Yeah, the 2 paintings together is implied sold for $1,925. Wouldn't you have liked to be the guy who painted one of them? That's a lot of money. Anyway, they sold for $1,925, so you said... Good, fairly straightforward first equation. Then we come to an interesting second scenario where it says if one of them had sold for $15 less. Well, let's just take the first painting, for instance. How would I show the first painting selling for $15 less? Right, the first painting sells for X, but if it had sold for $15 less, it would have sold for X minus 15, correct? And then it says, and if the other had sold for $10 more, well, how would I represent the other selling for $10 more? Y plus 10. It didn't sell for Y plus 10, it sold for Y. But if this had been 15 less, if this had been $10 more, then Bracken, in other words, what should I do here? In between them. X and Y are not equal to each other, class. But if the first had been $15 cheaper, if the second had been $10 more, then X and Y would have been equal. And there's our system for this one. Questions on this? Solve at your seats. check your answers once you've got it. Good. Good. And wait for it. Getting used to pressure-packed situations, that's all. So when like you're at the free throw line, you're down by a point, you get 2 shots. There's 0.3 seconds left on the clock, so this is it. There's no time. 3.3 seconds is not enough for them to go down and take a shot. You make both of these, you win the game. You make one, you at least force overtime. Pressure mounts, you sink them both. After the game, the reporters come and say, Brecken, how did you ever do that? It's like, pressure? Nah, that's nothing compared to the pressure Mr. Nasky's math class. Did you get these answers? Good to go there, excellent. Any questions at all on these word problems? All right, go ahead and take out your textbooks then and turn to page number, wherever the homework was, 278. Page 278, and some work that had really nothing to do with the powers and such, and roots that we've been working on of late. Some review, got an exam coming up in about 4 weeks or so. Exam that covers everything from the entire school year. So I want to make sure we review some concepts from earlier in the school year. Page 278, review numbers 1, 3, 5, 6, 9, and 10. And number 1 was an absolute value inequality. The absolute value of x plus 3 is less than 4. Now, class, when we think absolute value, we always need to think 2 words. Positive, negative. Anytime there's absolute value, we need to think positive, negative, because you understand whatever's in here, positive 4 or negative 4. But that's if it's an equation. This is not an equation, that's an inequality. Right? Kind of hard time getting that out there. It's an inequality. And so it's not going to be equal to positive 4 or negative 4. It's either going to fall, class, in between positive 4 and negative 4 or outside the positive and negative 4, right? Which one in this case, Matt? Inside. Less than always puts you inside. And my suggestion has been draw the number line, put the negative 4, put the positive 4, and graphically show the x plus 3 falling inside. In which case you understand we could write this as a compound inequality. What would that be, Maddie? There we go. And to solve, we simply put a everywhere to get. And there's our answer. How many had this answer to number 1 from the homework? All right, Maddie did. You remembered how to do this. Gentlemen, memory refreshed a little here. All right, let's take a look at number 3 from the homework, where we had the absolute value of x positive 5 is greater than or equal to 3. At any time, class, that we have an absolute value, we need to think what 2 words? Positive, negative. And of course, if it's an equal sign, equals positive, negative. But if it's an inequality, class, it either falls between the positive, negative, or outside the positive, negative. And in this case, Brecken, outside the positive, negative. Draw the number line. Plot the negative 3, plot the positive 3, and graphically show that the x plus 5 falls outside the positive, negative 3, in which case it's not going to be one inequality here. It's 2 separate inequalities. Brecken, how might we state the first inequality? Well, less than or equal to in this case, since the poor attempt at a solid dot. Maybe fill that in a little bit better. And then the other inequality, we'll say or. At 3 is not greater than, the x plus 5 is greater than. There we go. Either the x plus 5 is less than or equal to the negative 3, or the x plus 5 is greater than or equal to the positive 3. In both cases, Brecken, I solve in 1 step. To get? Greater than or equal to negative 2. And there are my answers, my 2 parts to the answer. And we get this answer for the second one. Again, Maddie, good to go on both of them. Gentlemen, we remember how to do this now. And that's the purpose of homework in many instances, just reviewing over some things. Looking at number 5, you're supposed to graph this particular inequality. 6x negative 3y is greater than or equal to 12. And this is a linear inequality. We notice we have both x and y, both to the first power. And for linear inequalities or linear equations as well, we can either use slope-intercept form or intercepts. Noah, which did you use to graph this particular inequality?
The
Intercept method. So you said that for the x-intercept, we plug a 0 in for the y, and when we do, we get x is 2. And then for the y-intercept, of course, we'll plug a 0 in for the x, and when we do, we get y is negative 4. And of course, we will go to our Cartesian plane, and we'll find a 2, 0 on the x-axis. We'll find 0, negative 4 on the y-axis, but we don't necessarily draw a line. That's if this were an equation. It's not an equation. There's no equal sign. It's greater than or equal to. So we have to consider 2 things. First of all, do we draw a line, Noah, or do we draw a dotted line? Regular line. Because of the or equal, we do indeed draw just an ordinary solid line. That's the first thing we have to consider. The second thing to consider is this line doesn't solve the inequality. This is just a boundary. Everything on this side or everything on this side satisfies that inequality. The question is, which side do we shade? And how do we know which side to shade? We test a particular point somewhere, anywhere on the Cartesian plane. But because we're lazy, we use 0, 0. We test this point right here. And we plug in 0x and 0 for the y, giving us 0 minus 0 is greater than or equal to 12. True or false? Very false. Which means this point doesn't satisfy the inequality, does it? Which means there's no way we could shade this side, which means we must shade the other side. And so everything on this side of the boundary line gets shaded in. How many had this for number 5? Once again, Maddie's on a roll. I'm not sure if that's just because Maddie's so much smarter than the boys, or if Maddie just remembers things better than the boys, or maybe Maddie put a little bit more time and effort into her homework than the boys. If it's either of the first 2, that's fine, because that's just the way God made her and made you. If it's the third choice, which I suspect, shame on you. Put the work in. Go back, look it up. If your thought on the homework, Gavin, I'm preaching to you too, just in case. If the thought is, I don't remember this, then look it up. That's why you've got notes. That's why you've got a textbook. Find the answers. Questions on this? Do you remember it now? All right, let's take a look at number 6. We got a 3x. Negative 2y is what you call less than 8. By the way, aren't you glad we're reviewing it now then if we've already forgotten it, and not waiting until right before the exam when you've really forgotten it? Let's see, Maddie, we come to you, which is a good thing. I think this is going to be the one she gets wrong. Maddie, what do we do? Walk us through. I would do slope-intercept form as well, because the intercepts don't work out very nicely. Yeah, I'm going to put the negative 3x before, just get the y equals mx plus v form, and then? Ooh. That's all code. Remember, flip that inequality when you divide away the negative 2. That said, you could still save yourself on the back end of this. Okay, keep going. All right. And so now, Maddie, you have the sign backwards, but again, that could actually not end up hurting you beyond, a casual point off later. You plotted your, as the y-intercept. So on the y-axis, from there you had to, the line's going to look very similar to this one. Not quite the same as far as the slope itself, but very close. Dotted or solid line, Maddie? dotted or dashed line, someone describe it as in this case, because we've got no or equal to. Now, Maddie, if you went right here to plug in your 0, 0, you would get it wrong because you had the sign wrong. But if you went back up here, your graph would still be perfect, which is why I encourage you always go back to the original just in case you did forget to flip a sign around. So let's go back to the original to plug in the 0, 0. Do I shade the side with the origin on it? Yes. Now again, if you plug it in here, you would have said no, you would have shaded the opposite side. But if we plug in here, then we'll shade this side. Did you get this graph, Maddie? Did you plug in the 0, 0 here? You had a solid line. Other than that, was it perfect? Okay, so you just need to remember solid line, or dashed line when there's no or equal to, solid if there is the or equal to, and then you did then go back to the original, plug in the 0, 0, so you did shade the correct side. So two little things, dotted line, and then remember, divide by the negative, flip the inequality. Gentlemen, assuming if we got this one wrong, we also got that one wrong? Questions? All right, let's go on to number 9. And let's find two numbers whose sum is 24 and whose product is 63. And if we were to write this using a system of equations, and it said using an equation, didn't say to use a system, but if we were to use a system, what would our first equation be, Noah? X plus y equals 24. Two numbers, x and y, whose sum is 24. What would our second equation be, Noah? X times y equals 63. Now, the reason I want to show this with a system, and I know the directions said to just use an equation. They didn't say to use a system. You realize you cannot use the addition method here. You don't have like terms. xy is not like to x or to y. Here we'd have to use what method, class? The substitution method. We would have to get one of these letters by itself. Maybe we kick out the x, and we call this 24 minus x. And then we take the 24 minus x and we plug it in right here for the y. To get x times 24 minus x equals 63. And we would solve from there. Which actually is exactly what you'd have to do if you didn't use a system of equations. It's really kind of the same thing, because you have to say, well, these two numbers, their sum is 24. Well, I, for instance, would know that 3 and 21, or 15 and 9, or of course 20 and 4. So if I call one of my numbers x, I'd have to take 24 minus the first number to get the second number, right? So if you were not using a system of equations, you'd have to represent your unknowns as x and total minus x, 24 minus x. And so when it says their product is 63, you would get the exact same equation either way. How many, regardless of which way you approach it, ended up with that equation? Does it make sense now how we should have worked it? Let's continue here then. Obviously we have to do what with the x, Brecken? Distribute. I'm just going to work it here. Distribute the x to get there we go. And all of a sudden, what kind of equation is this? It's been a little while since we've seen these, class. Has a squared in it. Starts with a Q. Quadratic equation. And remember we said the key to quadratic equations is to set the equation equal to 0. It's been a little while, hasn't it? Really a very good review exercise here. So we need to set it equal to 0, which means we either put the 0 over here on the left, or on the right, yeah, on the right, or we put the 0 over here on the left. But remember I said we always want the squared variable to be positive. It's not. So let's put the 0 on the left, and let's move everything else over to get what, Brecken? Good. And then, of course, we need to, what you call backwards FOIL, split up the x squared, class. And a positive sign tells us both the same, in this case, both negative. And How might we split up a 63? 7 and 9 comes to mind, but does a 7 and 9 give us a 24? No, so 7 and 9 is out. Well, let's think about 63. Is 1 times, does that give me a 24? Does 2 go in? No, it's an odd number. Does 3 go in? Yeah, 3 times 21. Would that give me a 24? Hey, yeah, there it is. All right, so 3 and 21. And so then remember, I'm going to take each of these factors individually, set them each equal to 0. So that x minus 3 is equal to 0, x minus 21 is equal to 0. And when I get the x's by themselves, what 2 answers do I get for x class? 3 or 21. Which means my first number is 3, or my first number is 21. My second number would be either 21 or it would be 3. So it really doesn't matter the order. My 2 numbers are 3 and 21. You would get the same thing here. You would get either x is 3 or x is 21. You plug into 3, y is 21. You plug into 21, y is 3. Again, what are your 2 numbers? They are 3 and 21 in whichever order you want to say. Questions on number 9. Does it make sense now? Let's look at number 10. Read that one for us if you would, Maddie. Consecutive integers. How would I represent consecutive integers, Noah? X and x plus 1. Good. So, again, not using a system here. And it doesn't say that the sum of my consecutive integers, we'll call this the first number, we'll call this the second number. It doesn't say the sum of the integers is 145. It says the sum of the squares. How would I write this, Brecken? There we go. X squared, the first number squared, plus x plus 1 squared, second number squared, equals 145. And that means I'm going to need to square a binomial. Go way back in your brain here. 3 steps to squaring a binomial. Class, say them with me. Square the first, square the last, multiply and double. Maddie, what do we get when we square the first, square the last, then multiply and double? There we go, square the first, multiply, double, square the last in your case. And of course we've got some like terms that can combine here, class. 2x squared plus the 2x. Now notice this is quadratic, isn't it? Which means I'm going to want to set it equal to 0, so let's bring the 145 over as a negative 145, Noah, to combine to get. But I got this 2 common factor, right? So let's simplify a little bit. Let's knock the 2 out of everything, Brecken. Well, negative 72 equals 0, because we want to keep, again, the quadratic equal to 0. Then we got to backwards FOIL and split up the x squared, class. X and x. What does this negative tell me? Positive, negative. Signs are going to be different, right? One's positive, one's negative. I don't know which is which right now. And I got to split up the 72. There's a lot of ways to split up a 72. Thoughts? 8 and 9 would give me a 1, specifically if the 9 were the positive and the 8 were the negative. Then it would give me the positive 1x. So when we set both of these equal to 0, I get what? 2 possible answers for x. Negative 9 or positive 8. So my first number is either negative 9 or it's positive 8. What's the next consecutive integer after negative 9, class? Negative 8. All right, if you're counting up the number line, after negative 9 comes negative 8. If 8 is my first integer, what's the next consecutive integer? 9. And there are my answers. It is either negative 9, negative 8, or 8 and 9. Did anyone get these answers here? We have done one like this. That other problem, we've never done one quite like it before. I was curious to see how you do. We have done problems like these before. Maybe it's been a little while. Questions? Questions on quadratics. Again, I feel like this review lesson, this review exercise, more than others, draws on some concepts we haven't had to use in a while. So I thought it was a really, really well-timed exercise. We've got just a little bit of time remaining, so I just want to recap some things we talked about in our last lesson, going back to this idea of powers, this idea of roots. Again, powers we're memorizing. Roots, technically, we're also memorizing, right? A root simply says what to this other power would have given us this. For instance, the square root class of 324 would be what? Square root of 324? Maybe I heard it, maybe I didn't. 18. Because 18 squared equals 324. By the way, quick recap here. If I were to ask the question written out, what do we call this root symbol thingy, class? Think of people protesting in Minneapolis. Radical sign, radicals holding up sign. Anyway, radical sign, that's not going to help you remember it. What do we call the number inside the radical sign? The radicand. Also inmate number, whatever. And what do we call, that's not entirely funny actually. What do we call the number that, we can't actually see it right here, but it's the number that tells us which root we're taking? The index. Now, we can't see one here because it's an understood 2. If we were to take some other root, then we would obviously have to write that particular index. All right, but we've begun looking at a different type of exponent, one that actually had a root built into it. It's called a fractional exponent. So find in your notes where we left off in our last lesson, fractional exponents. And I said if we've got something like x to the 5/3 power, this is the same thing as taking the root of a power, because when you take the root of a power, class, you divide the exponent by the index. Is that statement in your notes somewhere? To take the root of a power, divide the exponent by the index. We'd spend some time practicing with this. For instance, we might take the 4th root of n to the 12th, n to the 16th, and if we did reckon, we would get good, because we would just divide the exponents by the index. And I said, well, if that's true, and division is what's going on between exponents and index, and we use a fraction bar to show division, then that means that this apparently is the power that we took the root of. To take the root of a power, divide that exponent by the index. So that x to the 5/3 could be rewritten with a radical sign. How might it be written, Maddie? Cube root of x to the 5th power. Do you have this in your notes somewhere where we left off last time? What if we had m to the 1/2 and n to the 5/2? How do you suppose we'd rewrite that as a radical, Noah?
The square.
Square root.
Yes. And
There we go. The square root of n to the 1st, n to the 5th. And we didn't necessarily have to write the first power there, but good. The index should be 2, and the exponents should be 1 for the m and 5 for the n. Does that make sense? What if we had x to the 1/5 and y to the 4/5? Actually, let's make this x to the 3/5 and y to the 4/5. Brecken, how do you suppose we'd rewrite that with a radical sign? There we go, the 5th root of x cubed y to the 4th. What about this one, though? C to the 1/2, d to the 4/3. Do you see a problem here? We have 2 different roots. That would mean 2 different radicals, right? But mathematicians are Lazy. They don't want to have to write two different radicals. They'd rather write just a single radical. Any thoughts on how I might be able to get into just writing a single radical? Get a common denominator. Get a common root. What would the common denominator be here, class? 6. So if I got a common denominator of 6, then we could rewrite this class as c to the... How many 6? Multiply top and bottom by 3 to get c to the 3/6, d to the 8/6, right? Multiply top and bottom both by 2. And now, kind of working our way around the chalkboard here, we have a common index, a common root. Maddie, we could write this as one radical now. Good. Questions on this? Do you remember talking about this in the last lesson? It's been a little while. Make sure you have in your notes that for a fractional exponent, the numerator represents the power or the exponent, and the denominator represents the root or the index. Make sure that's in your notes. If you don't see it, write it down. Even if you'll find it later, it doesn't hurt to have it written down twice. Let me go ahead and give you an assignment to work out now there at your seats. Practicing converting fractional exponents. You can go ahead. Converting fractional exponents into radicals. N to the 3/5, R to the 2/7, and a couple more. All right, Brecken, the first one? Very good. The 5th root of n cubed. You know what the second one?
The 7th root of r squared.
7th root of r squared. Excellent. Maddie, the next one. Excellent job. And then the last one, Brecken?
4th root of j to the 1st k cubed.
There we go. And I'm going to leave the understood first power there. Did we get all 4 of these correct? Do we feel comfortable rewriting fractional exponents as radicals? We could do it the other way around, though. Suppose, for instance, we had the cube root of a squared b to the 1st. Well, again, if you'll remember, class, say it with me, that to take the root of a power, divide the exponents by the index. Again, to take the root of a power, divide the exponent by the index. And remember, division is shown with a fraction bar here. How do you suppose we would rewrite this with fractional exponents, Noah? Good. Exponent divided by index. Good. Exponent divided by index. Suppose we had the 7th root of a cubed b to the 5th. How would we write that, Brecken, with fractional exponents? There we go. Exponents divided by index. Suppose we had the square root of m to the 5th n, Maddie. How would we write that with fractional exponents? There we go. Supposing we had the 5th root of a squared bc to the 4th. How would I write that, Noah? Excellent. And one more here as we finish up. Suppose we have the 4th root of a squared b. Brecken, how would I write that? Initially, yes. Questions, comments, thoughts, class? You can reduce fractions, and even with fractional exponents, we will. So, Brecken, your final answer. There we go. And that would be the final simplified answer. Do we understand this? All right, we're going to work on that more in our next lesson. Make sure you study over squares, cubes, powers of 2 for another quiz in our next lesson. And have a wonderful rest of your day.